Actually, I do. These are stood strings. They make an allocation, right? They're not compiling things. So these are inherently, like creating this object here is a runtime operation, right? Because it's going to have to create a stood string. Alright, so you can also remove stuff. Just tell the index is a compiling number and it's going to do the trick. You can iterate, like we already saw. So for each animal you can do stuff. And here, auto A will have a different type each time around for the first one it's going to be a cat, then it's going to process the dog, and then it's going to process the fish. So it's exactly the same as saying like, take this lambda, call it with first element of the tuple. Okay, that generates one lambda. Well, one lambda, operator parent's body. Then do the same for dog, do the same for fish. Yes?
Can you index by type? That you do something like animal, record, dog?
The question is, can I index by type? Not with a tuple, because a tuple is really like it's really the same as a vector in that world. But I'll be talking about compile time maps where you can do that. Yeah.
When you're removing or inserting, can you remove and insert to the same tuple?
Excuse me?
When you're removing and inserting, can you remove and insert to the same tuple?
The question is, when you remove an insert, can you remove an insert in the same tuple? No, because the type of the resulting data structure is going to be different from that of the first data structure. So it doesn't even make any sense really to do that, because like, if I remove from my animals, it used to be a tuple cat, dog, fish. Now it's cat and fish. These are different types. These are different structs. If you remember what tuple generates in terms of like, struct and object layout, it's completely different. It's just a different thing. So it doesn't make sense to do these operations in place. No. Yes.
You said you can't index by type. Isn't there a stood get that takes type and returns the...
The question is, you said you can't index by type. Isn't there a stood get that does that indexes by type? Yes, but HANA doesn't provide it. It's a design.
It wouldn't work.
It wouldn't work because I decided not to make it work. It's like I said, it's a design.
It's like an associative lookup in a non-associative structure.
Exactly, it's like associative lookup in a non-associative structure. I personally consider stood get indexing by type as being hard. I believe it would be much better handle. I mean, yeah.
But
why does it fail when you anyway?
But you can have multiple types. The same type will repeat multiple times in
yes,
different
you do.
positions. So
You can do the same with stood tuple, except if you happen to try to index by type and there are multiple types, then you get a compiler error. Instead, what I do is, and I'll get to there, but I provide a compile time map which says you cannot have two things that are associated to the same key. So then it basically does the same as a tuple, and it's actually implemented as a tuple behind the scenes. But I believe it gives for a better separation. Of like, okay, this data structure is indexed by integers by position, and the other one is indexed by arbitrary keys that are comparable. Yes.
Can you still access animals after you create fewer animals? Does it copy the strings? Does it move the strings?
Can you still access your animals after you remove your animal? Well, since I created a new structure, I didn't, here it's fewer animals, and here is animals. So animals is still there. I have copied each member of animals into the new structure. So I've made a copy effectively. And so, these guys are still around. Now, if you don't want to have a copy, if you're like, animals I don't need anymore, use stood move. And HANA is going to be like, oh, you don't want these guys anymore? All right, I'm going to move from them. And so all of these guys are going to be moved from, except for 0, 1, except for the dog, which I don't need to do anything with, because I'm just creating a new structure which ignores the dog. So I'm going to move from the cat, I'm going to move from the fish, the dog I don't care about, and create a new tuple from that.
How would that work? Where would the stood move go?
student move animals. Here you're like, I want to remove stuff from my animals, but I don't need my animals anymore, so I tell Hannah by saying, you can student move from my animals whatever you like. And then Hannah's going to be like, all right, I'm going to optimize that.
It is still going to have a stale identifier lying around. You have to make sure that you don't use it later if you if you do a move.
Yeah, sure. Well, I mean, then you consider animals as being moved from object. If you like taking risks, you can tell maybe that, oh, but I didn't quite move from the element at index 1, but I wouldn't do that. I would just consider it like it's moved from. I'm going to try to blaze a bit more into my slides because I have quite a few still left. Okay, so you can iterate through a tuple. We can transform a tuple just like std transform. We can Hana transform. So just the same. So you have a vector tuple, but it's really a vector of things. And then you give a function. So I want to get the name of each animal, and then I call transform on it. It gives me the name of everything, and that gives me a tuple of strings. It's that simple. Yeah.
Can you do a heterogeneous transform? Kind of switch, I am now in field 1, return a.name or b.
Okay.
There's some
So the question is, can you do a heterogeneous kind of transform? Yeah, sure, you can. You can. The way you would do, well, there are many different ways of doing it, but let's say just one way of doing it is instead of providing this, you provide like a function object with an overloaded operator parens, and when it gets called with a cat, then it does something. When it gets called with a dog, then it does something.
Can I distinguish by position instead of the type?
So for transform, okay, well, what you do is Hana zip, Hana range from 0 to the length of your tuple, and then, right, it's pretty functional, but that would give you a auto I, which is a student integral sequence, integral constant, and then a which is your animal, and you can do whatever you want based on the index at compile time. So that's possible. Yeah, things can be composed. Yeah, just essentially the same as you would do in a functional template, STL. Right. So you can transform stuff. You can remove stuff. So this is remove if really. So remove if the type of A is fish. So if you're fish, I don't want you anymore. It could be, obviously, it could be like remove if the size is greater than or equal to something. Doesn't matter. But like as long as you have a predicate which is able to tell its result at compile time, then you can filter it. Yes.
One more fundamental question. You always work on instances of things here, if I understand correctly. So
Yeah.
you have an object animals.
Yeah.
It's not the type animals that you
Yeah, but decal type.
iterate.
Yeah, but decal type gives me a ANA type, which represents the type of this object. It's like if you do decal type in C++.
But you always need an instance. So this is somehow, there's a fundamental difference to, I think, MPL, which not necessarily needs instances of things.
Right. Well, if you have a type instead of an instance, then you have a HANA type here, right? Let's say A isn't HANA type.
No, but I mean you have animals. Animals is an instance. Can I pass something into remove if or into...
If you just want to filter the types themselves, cat, fish, and dog, as types, then you instead of creating a HANA tuple of cat, fish, and dog, you're going to create a tuple of HANA type cat,
Okay.
HANA type fish, HANA type dog. So you're going to properly say,
Right.
like,
and then
I am...
an instance of this.
And then you have an instance of the type, of the HANA type whatever.
Okay.
And then here you're going to be like, if type is equal to HANA type fish, right, then it works.
So
And
what is the type of mammals after the return from the remove if?
well, HANA tuple cat, dog, and that's it. Because I removed the two fishes.
But the compiler needs to know the type of, what is auto mammals? What does auto bind to?
HANA tuple, angle bracket, cat, comma, dog, angle bracket.
Well, you're removing some things from that tuple.
No, I removed fish and fish. Remove if the animal is a fish. Therefore, I remove the elements that are fishes. Therefore, what I end up is a tuple with a cat and a dog without the fishes.
Right, so you have a tuple of cat and dog.
That's right.
But you don't know this at compile time, so how does...
Well, yes, I do, because I know the type of A at compile time. I know this at compile time. Therefore, this equal here returns stood true type or stood false type. Therefore, my remove if can know the result of the predicate on each element at compile time. Therefore, it can...
Okay, so the lambda has to be...
has to return a
You don't,
something that's not at compile time.
and you don't need to say const expr anywhere.
Const expr is completely unrelated to this. Yeah. So no, you don't have to write const expr anywhere in there. You couldn't even, because in C++14 lambdas cannot appear in constant expressions. Or no, they can appear in constant expressions, but they like...
But doesn't the compiler need to know that this lambda returns a compile time boolean?
It does, because I return stood true type or stood false type. I don't return true or false. If you do, you're gonna...
Okay, so this equal is not a real equal.
It's a real equal, except it's a compile time equal. And if you want your thing to this is why I say that this stuff is more powerful than const expr, because if I was returning a const expr-ish boolean, then from inside the remove if I could never tell whether it's actually const expr boolean or did the guy decide to change his lambda and now he's asking the user whether I should be returning true or false. And if you do that, then the compiler is going to have a really hard time still being around to compile your code on the fly when your user decides to say false instead of true. So essentially, this guy here has to return something that is known at compile time in the form of a compile time boolean. The same thing as a compile time number that I talked about earlier, except it's a compile time boolean. So it's something which contains true or false, but that's encoded in the type of the thing. Right. So you can sort, although the algorithm is quite involved, to be honest. I am trying to optimize that guy, and it's not easy. But yeah, so you can sort on an arbitrary predicate. So I sort the types here, and that's related to your question somewhere there, about like, I'm always working with instances. Here I'm not working with instances, I'm working with actual types. So that's a type list, right? That's a bit verbose, but you can use Hana tuple underscore t, and then just say char array 10, char array 5, and char array 1, and it's going to be it's going to be a variable template equivalent to this guy anyway. So I create a tuple of types, and then I sort them based on my custom predicate, which says on the size of it, right? So here I get my sorted stuff. And nice thing, I could actually use static assert in this case, because I know that, because the comparison here, the result of the comparison really only depends on the types of the things, and since the types are not compile time, surely the result can be computed at compile time. And indeed, I could be using static assert. Except I would need to use const expr here, and then I can't have this lambda, so not quite, but I mean conceptually we can. And in C++17, when we have const expr lambdas, that's not a problem anymore, yes.
Just 10 minutes more.
Alright, 10 minutes will fly through. I can partition so that stood partition, instead of partitioning your range as stood partition does, since we can't do anything in place, we return a pair which contains two sequences. First, the sequence that matched the predicate, I believe, and second, the predicate that doesn't match the predicate. So yeah, only dogs first. So only the things that match the predicate in the first element of the pair. So it's a sequence of the things that match, so on. You can search for stuff. So you have a findIf, right? And it returns a kind of stood optional, but it's a compile time optional. Basically, you take the whole standard library and then say compile time before it, and it's there. So you have a compile time optional. It's like a maybe value. It's a value that might be there, might not. If you didn't find it, then it's not there. If you found it, then it's there. And obviously, you can know whether this value is there at compile time. So if you hadn't found this guy and you try to dereference it, so to access the optional value inside the optional, it would give you a static assert. It would give you a compile time error.
What's the type it returns?
What? This?
Yeah. What is that one?
It's like HANA optional
Oh, it's optional.
of,
Okay. I see. Okay.
of dog. And this guy, which is not found, is like HANA optional English bracket, English bracket. But that's implementation detail. Don't rely on that. It'll break your code. You have to read through the documentation for that. Yeah. Like, what type is with, like, what is, the type of what thing is what is like some often considered an implementation detail because, anyway, because of a lot of details. So I want to go faster. So you can count stuff. You can reverse, just like std reverse. You can do a bunch of algorithms. You can unpack. So unpack is equivalent to std experimental apply. Essentially, what it does, you give it a function, and you give it a tuple, and it's going to call the function with the elements inside the tuple.
So it's like a transform that guarantees the same type everywhere, so that you can put it in there.
It's like a transform, except it guarantees the same type everywhere, so you can put it in the transform. I don't.
So your transform
Yeah.
could return different types for different different field.
Yeah.
So it returns a tuple back. In this case, your transform guarantees to return the same thing. So then
It's not a transform.
Hmm?
This is not a transform. I'm calling f, which with each element of the tuple, I mean, expanded into f. Whereas the transform would be f of the first, f of the second, f of the third, and put that in a tuple. Now I'm just calling the function f with each element, with every element at once, right?
Oh, okay.
This is a variable lambda.
Okay.
Right? Okay, so if I want to show anything meaningful, I've got to... Alright, so if we go back to element optimization. So our problem was find, the most back representation. Well, we can use a tuple. It's quite easy actually, and it looks it's not that far actually from what we would write in real C++, right? You remember we had in our pseudocode, we had like std sort, my types.begin, my types.end, a lambda, which was based on alignment, and then we had basically returned a triple with the proper types in it. And so here we just HANA sort based on their alignment on the align operator lifted to HANA, and then we essentially create a type which is the triple that has the types in it, in the sorted in the reverse order of alignment requirement, and then we return that type. And here I just create essentially my vector of types. Then I figure out, okay, what is the result of my computation? Well, it's that triple here. All right, now I can instantiate an actual object with it. Yes.
In your unpack, you expect a lambda or some function object. Do you have something that unpacks in place, so like into a variadic template? So I could do like my function and unpack tuple, and then it just expands up the types if my function is variadic.
No, and the problem is not related to HANA. The problem is in the language. An overload set cannot be passed as an argument to a function, so that you could not possibly pass an overload set, which is a template function, well, in this case, it's not technically a template function, but anyway. So you can't pass that to an algorithm. Dot, like end of the story. The language will not allow you to do that, but there are plans to change that.
Okay.
So you can. All right, and this is not interesting. Okay, so I have a map. I'm going to really blaze through. So essentially, the map associates anything which is known to compile time. Here, that's a compile time string. So it's like a compile time number, except it's a string. And you create it with _s, and And well, yeah, so you can map things that are known at compile time to other things that are not necessarily known at compile time using this map. Then you can access keys, just like you do with studmap. You can say, hey, do you contain that guy? And obviously, it will know whether it contains it or not at compile time. So that's static assert, not assert. You can insert new stuff in your map. If you try to insert at an index which already has a thing in it, I mean, sorry, I'm not clear at all. If you try to insert an element with a value associated to a key which is already in the map, then HANA is just gonna not do anything, or that's lame. I think it will just not insert it, or maybe it's gonna update it, but check the docs anyway. So what I mean here, I want to put the emphasis on the fact that we are enforcing the uniqueness of the association between keys and values, which is the first thing ever in metaprogramming. It's really costly for us to do that at compile time, but we still do it because otherwise it makes working with the map completely insane. For anybody that has used Fusion Map, they know what I'm talking about.
And you can use anything as keys? Any type? Or should it must it be like keys?
Anything that is not that can be compared to compile time. So if you have an operator equal, which returns a std true type or a std false type, you're good to go. Otherwise, if you return true or false, you will get some compiler error, which you might make.
So what is the convention that you follow for underbar S and underbar C for tuple versus map? The underbar S and underbar C operators.
Underscore S creates a string. C creates a constant. Right? Okay, so now's the. I'm almost done, Bryce. Bear with me. This is the example of
It wasn't a hard 10 minutes.
Sure. All right. So here's the here's an example that could happen in the real world. So we have some events. We know all the events at compile time. Fair enough. Our system is, not extendable by users. So we have a certain number of events, here they are, and they can happen. So we'd like to have a system which knows all the events at compile time, and then we can register new functions to events. So on foo, I would like you to do this, and then that, and then on bar, do this, and on baz, do that. And if you try to register a callback to an event which is unknown to the system, you would like to have a compiler error because you know all your events at compile time. Therefore, there's no reason in the world. I mean, we're in C++. We don't settle for dumb dynamic things. If you can fail at compile time, you shall fail at compile time. So you would like your system to be able to do that for you. It's not quite easy to do that in C++ usually, but with the tools that we've developed, it's possible. And it's even quite easy. And then you can trigger events. You can say, hey, I just saw Baz go by. So trigger Baz, and then it's going to call all the callbacks that have ever registered to Baz. And if you try to trigger an event which is unknown, then it should also be a compiler error because, well, the set of possible events is bounded at compile time. Therefore, anything that goes out of that should be caught at compile time. If you're doing like Mars rover, you might want to, that's the kind of thing that you might want to be aware of. That somebody, oh, I meant to say like land, but I said like one end instead or something like that, and then woo, everything breaks. So
it's like enum on steroids where you could have any Unicode as part of your
string?
Yeah, as part of your enum identifier. So that's
right.
effectively an enumerated type.
That's effectively an enumerated type. You mean the underscore S here?
Right, I mean, that's... So underscore S makes an enumerated type out of strings, if you like.
Precisely, yes. Yes. Oh yeah, by the way, this here is not strictly standard C++. It's like an extension, but it's provided by GCC and Clang. And I have written a paper which I will be presenting in ACCU to make this actually standard C++. It was already proposed, it was rejected. I think it's stupid that it got rejected, and I'm trying to bring it back. So, yeah, the string literal template. Yeah. Yeah.
Yeah, I was.
They said, come back with additional machinery for compile time processing, and I'm like, we don't need additional compile
I
time.
agree, you can't write Metaspirit without this, so I agree.
There's just a lot of things that you can't do without this, and you need, as you will see actually, you need little to no additional compile time string processing whatsoever to make use of this. I should actually use this example in my paper. Yeah. I'm going to do that. And I was like, which examples do I have? Well, I have one right here. So I create my event system. What I do is, so first my callbacks, I'm going to store my callbacks in a vector of functions, you know, that return void. That's fair enough. Now I'm going to make a map which associates each event to a list, well, to a list of its callbacks, right? And then I default construct this event system. So this is essentially a mapping from you know, all the events to their list of callbacks. Then, so I store, so here I create my event system with that storage. Here's the storage. Then when I want to register a new callback, what I'm going to do is specify the event, and so I'm going to check, oh, do I know about this event, by saying like, are you contained in the map? If so, then I can push back my new handler to, you know, this, to the list of callbacks associated to that event. If not, then, well, I break it, you know, issue a static answer. So. Is everybody following me here?
So this example doesn't work, assumes a same signature for all the events, but we can have different signature for different events and still we can accomplish it, because that's what a more real-time, a real-life use case would be.
So the comment is, this assumes that all the callbacks, all the handlers have the same signature. Yes, it does. The only way not to have this, and I'm not quite sure about the real-world thing, but
I mean, we have an exact requirement like this, and I have,
you have different signatures.
like based on which event, you might pass 2 arguments, you might pass 5 arguments based on what are the things that change for that event.
Right. Yeah, it would be quite easy to extend it, saying, okay, so what you would do then is, instead of just saying make event system foo, you would have like make event system foo and say like, hey, by the way, here are the possible things that can be passed on a foo.
Yeah.
Like when a foo is triggered, here are the possible things, parameters that you may pass. Yeah, okay, so that's right. Okay, yeah, I can imagine that in a real life system, definitely. This is a simplified way, but feel free to base an implementation.
Yeah, I'll make a definitely prototype.
Because you know the next slide is basically the end of this example, and without a proper metaprogramming library, it would be a pain in the ass to do. So now, if I want to trigger an event or some events, then for each event, I'm just gonna make sure that I know that event. Otherwise, I fill out compile time, and then I'm gonna call each handler. So for each handler associated to this event, I just call the handler. And in your case, you would have something like when you trigger an event, you also pass in like the parameters that you want to call it with, and then you would forward the parameters, the arguments rather, to this handler here. That's what you would do. All right. So the applications are almost endless. Like there are many different applications. It's a kind of weird, crossing between compile time and runtime. It's really interesting, and it has many uses. So we saw JSON, class registration, element optimization, and like a kind of event generation system. But there are also stuff like dimensional analysis, serialization of other protocols, which would greatly benefit from having proper reflection support. But still we can do with a few macros. And automatic parallelization, like I mentioned, domain-specific languages and expression templates. Like you create a tree, representing like your matrix operations, and then you walk that tree and you simplify the whole thing. So that's like the classic use of metaprogramming. All right, so HANA is in Boost. It's in since 1.6.1. So use it if you can. it requires a C++14 compiler. So maybe you don't have that chance, but if you do, then consider using it. Help us improve it by submitting bug reports, feature ideas, and that kind of stuff. It's really, really important. I'm just right here. Submit something on GitHub, and I will try to get back to you. Yes.
Does it work with GCC now?
It works on GCC 6, not GCC 5 or anything.
How about Clang version?
Clang since 3.5, and that's all. Clang 3.5 and up, and GCC 6 and up, but there's no up. So, yeah, and MSVC, no, sorry.
It doesn't work on more
Yeah,
than
I mean,
C++?
yeah, what?
It doesn't work on more than C++?
I don't know, I guess not. I guess not, right? Yeah, so, all right, so that's it. I mean, thank you very much for
If you have more questions for Louis, you'll be able to find him at the Tide House, which is...
Definitely.
Where's the Tide House?
I don't know, man. I
It's
don't
on
live here.
Franklin and Villa Street. The intersection of Franklin and Villa Street.
Yeah.
Google Maps.
This is all foreign territory for me.
Would you consider putting your slides up on GitHub? maybe?
Yeah, we put the slides for this meetup group. There's a GitHub for this meetup group that's linked on the meetup page.
Yes.
So they will be,
Yeah, and this talk I already
Yeah.
made actually at C++ Now in May. So that talk is currently online on my website here.
Oh, great.
But it's going to be easier to find if you go there on GitHub. And there's a video on YouTube if you go look for BoostCon videos. There's the video that like if you want to go back and say, oh, what did he say at that point or something like that, you can actually listen over again. Basically the same way.
Great talk, thank you.
Thank you.
can you copy it to a flash drive?
Yes. Yes. You like that? One moment. Thanks.